Hello. Today's video is to talk about tangent lines and their cousins, normal lines. We've been working with calculus so far, and calculus has told us how to find a function that will tell us the slope of a tangent line at any point. And if we know the slope of the tangent line and we know the point through which the tangent line goes, then naturally we should be able to find the equation of said tangent line. Then normals are perpendicular, and it seems kind of weird that they would even have a name, but they're perpendicular to tangent lines. Oftentimes, normals are used in like vector fields and stuff, so it gives you a chance to see textures of three-dimensional spaces and get a sense of the direction of the surface. And there's other purposes for normals, which you will see. Incidentally, the method for finding the equation of a tangent and a normal is really straightforward. See, here I have a function, and again, the setup was I needed to find the equation of the tangent line, the red one, and the normal line, the blue one, at the point where y equals 3. So where y equals 3, I have to find out that x equals 7 in order for that to happen. So I just put in 3 for y and found x equals 7. So now I have enough information to do my work. All I have to do is take the derivative of that function and evaluate the derivative at 7. So f prime of 7 is 1/6. So then I find the equation of the tangent line using the point-slope formula and take the opposite reciprocal of the slope and do the same thing, and you'll have the equations for the tangents and the normals. I'll show you another couple examples real quick. The first is we have this function, x squared plus 4 over the square root of x, and we need to find its derivative when x equals 4. So there's a lot of good information to start with. I'm going to begin by finding the derivative so that I can find the slope. Derivative is also oftentimes known as the slope function for that very reason. Before I take the derivative here, I have to reform my function. I actually distribute the divide by square root of x so that I can get everything into power form. And then when I take the derivative using the power rule, it's really straightforward. A little bit of cosmetics and some cleanup. Now I'm going to find the slope of the tangent line. So this function will tell me the slope of the tangent line. And here's my notation. The derivative of the function when x equals 4 can be evaluated as such. Convenient that they gave us a perfect square to evaluate our tangent and normal. Isn't that nice? So this is 11/4, which is the slope of the tangent line, and to find the slope of the normal, it's the opposite reciprocal. So instead of dy dx, it's the opposite of dx dy, evaluated at 4. And I don't have to fill it all in, I just have to take the opposite reciprocal of the slope that I just found. Now that I have the slope, and I know that when x equals 4, I have a tangent line, and I know the slope of the tangent and the normal, I just need to find the coordinates of the point when x equals 4. So before I can find the equation of the tangent line, I've got to find out what f of 4 is. So I go back to the original function. It says f of 4 is 10, which is confirmed, by the way, by my Desmos tangent and normal finder. By the way, there will be a link on the Haiku page for this application. I basically programmed Desmos so that whatever function you put in, it will find you the equation, it'll graph the tangent and the normal for any point you want. So I can verify everything I do by Desmos. And so the first thing I did is when x is 4, y is 10, that's confirmed already by my graph. And so I can keep on going with the point-slope formula, solve for y, put it in the proper form, and make sure that it's correct. So first of all, I find the y-intercept of -1 matches my graph, and the slope of 11/4 also matches the graph, so I definitely know I did the work correctly. For the normal, exact same thing. We just use the different slope, but the same point. And the rest of it is all mathematical cosmetics. Keep in mind that when you use Desmos to check your answer, I have a Desmos normal and tangent grapher. It won't give you the equation of these lines, it'll just graph them for you. So what I'll do is manually type in the equation of my normal and manually type in the equation of my tangent and make sure that it overlaps the two that were formed by the Desmos. So just another quick example. Notice we have some trig here, isn't that fun? Taking the derivative first. Remember, the derivative of the tangent is the secant squared, the derivative of the sine is the cosine. Now that I have the derivative, I need to find the slope of the tangent and the normal, so I evaluate at pi over 4. Now I know why I had to know all those trig ratios, so I can do this calculus. Once I know the slope of the tangent is 4, I know the slope of the normal is -1/4, I know the coordinates of the point are pi 4, 1, then I just find the equation of the tangent using point-slope form, see that it matches my graph, and I find the equation of the normal in point-slope form, and see that it matches my graph. And well, I'm going to leave this one forward and just pause the screen. I don't want to talk at you any longer, but feel free to pause the screen and read this. Otherwise, the notes will be available on the Haiku page, and you could practice with these exercises. You'll find these in the textbook, or I'll have them posted online. So thanks for watching.